Welcome to the channel. In this video, we will talk about the difference between writing the data to the file in text mode and writing the data to the file in binary mode. Mainly, we're going to be talking about the difference when using the function like fprintf and fwrite. So here, in order to explain this, what I have done is I have first created a pointer of type file, and then I have created an integer variable called as x, and I have stored a value of 65 in this variable x. And after that, what I have done is I have opened up a file in binary write mode, and I have written the data of this variable x to the file. And here I have used the fwrite function, and this function writes the binary data to the file. Just like the way the value of 65 is stored in the memory, it will be written to the file. And that value will be stored in this numbers_binary.bin file. And after that, I have closed that binary file. And then what I have done is I have opened a file called as number_text.txt. And I have opened this file in binary write mode. Again, just because I'm opening the file in binary mode doesn't mean that I have to only write the binary data. We can write text data also. And after that, what I have done is I have used the printf function, and I have written the value of 65, which is stored in this variable x, to the file. So here, this program actually creates two files. One file called as number_binary.bin. This file contains the value of 65 just like the way it is stored in the computer memory in binary form. Second file called as numbers.txt is a text file. This will contain the value of 65 just like the way we see the number 65. So now when I run this program, what happens? We don't have anything as the output from this particular program because I haven't displayed anything. But this program creates two files and it writes data to these files. So let us first take a look at the binary file, that is number_binary.bin. Here I have opened up that file. Now here this file contains the data in binary mode. But here, in order to explain this, I have opened up that file in a normal text editor which shows the data as text. And that's why this number_binary.bin file will look something like this. It will display A and then null, null, null. Now, important thing here is this file has 4 bytes. A, null, null, null. If I go back to the program, if I talk about this integer variable x, this variable, since it is of type integer, my system here uses 4 bytes of memory in order to store that. So if I convert this number 65 to binary form, then it will look something like this. Now here, this particular byte is called as most significant byte, and this last byte is called as the least significant byte. Here, this number 65 will be like this in 4 bytes representation. Now this value that I have mentioned here is the number 65 represented in binary format. But the way this data is stored in the memory will depend on the endianness of that system. Endianness refers to the order in which the bytes are arranged in the memory. Now mainly there are two choices when it comes to endianness. One is called as little endian. The second one is called as big endian. When a system is little endian, the least significant byte is stored in the smallest memory address. In other words, I can say that when a system is little endian, the least significant byte is stored first. When a system is big endian, the most significant byte is stored at the smallest memory address. In other words, I can say when a system is big endian, the most significant byte is stored first. Here I have the little endian system, and that's why the least significant byte is stored at the smallest memory address, or it is stored first. And here in this binary representation, this is the most significant byte and this is the least significant byte. So since I have the little endian system here, the least significant byte will be stored first. So in computer memory, it will be this value first and then the remaining bytes. Now what happens is, when we have a text file, what does the text have? The text have characters. For each character, 1 byte of memory is used. Now here, this text editor is trying to read this number underscore binary file as a text file. So it is reading from the memory and it is interpreting those values as the characters. In programming, all the characters are assigned a numeric value depending on the encoding standard. Here, if we assume that we use the ASCII standard, then the ASCII code for the letter A is 65. Now look at this value that is written in the file. Since I have the little endian system, the least significant byte is stored first. So it will be 65000. So here, this text file is trying to read from that. So when it reads 65, it matches it with the character depending on the encoding standard, and it happens to match the letter A. And that's why it is interpreting that data as letter A, character A. And then we have 000, generally considered as null values. So it is displayed as null, null, null. So that's why we get the content here. So here we have the value 65. When we convert this to binary form, it will look something like this when we represent it in 4 bytes. And depending on the endianness, the system stores the bytes in some specific order. Since I have the little endian system, the least significant byte is stored first. And that's why in computer memory, the values are stored like this. And this fwrite function writes this data to the file. So the file will contain the values like this. And when I open that file using a text editor, the text editor tries to assign each byte to a specific character depending on the encoding standard. And here the first value that we have is 65, which will match the alphabetical character capital A, and that is displayed here. And then null, null, null. So that's why we get the values like that. Now when we use the fprintf function in order to write the data, what happens? This fprintf function writes the data to the file in text form. Again, when we talk about the text, what does the text have? It will have the characters. In order to represent the characters in programming, encoding standards are used. Depending on the encoding standard, each character will have a numeric value. Since we can't really store the characters in computer memory directly, everything has to be stored in the form of zeros and ones. We assign numbers to a particular character depending on the encoding standard. So here, when we talk about writing text content to the file, what this fprintf function does is it writes the data just like the way we see it. For example, this variable has the value 65. Now when I want to represent it using text, it will be 2 values, 2 characters, 6 and 5. This fprintf function writes 6 to the file, and again, in order to write 6, it has to write a number depending on the encoding standard, and that value happens to be 55 for the letter 6 if we use the ASCII standard. And binary representation will be something like this. So this will be stored in the file. And then for the character 5, depending on the encoding standard, let us say ASCII, it is 54, and the binary representation will be like this, and this is stored in the memory. So if I open up this numbers.txt, we can see we get 6 and 5. But internally, what exactly is stored? The binary value for 6 is stored in the memory. The binary value for 5 is stored in the memory depending on the encoding standard. For 6 in ASCII, the value is 55, and that is stored in the memory. And then for this 5, the ASCII value is 54, that is stored in the memory. So this text editor, when reading from this text file, it reads a byte, and whatever the value it has read, it will try to assign that to a particular character depending on the encoding standard. It will read 55 in binary form, assigns that to letter 6, and it will display that. and then the 55 in binary form, it will assign with the letter 5 and it will display that. So with this fwrite function, we are writing the data just like the way it is stored in the computer memory. But when we use this fprintf function and when we write text data, each character will be stored depending on the encoding standard. Now I hope you guys understand what I'm trying to say here. So this is it guys for this particular video. Thank you for watching. If you like it, hit the like button. If you don't like it, hit the dislike button. If you have anything to say, write that in the comment box. For more tutorials, subscribe to the channel.